So another way we can represent numerals, or we can build physical models to represent numerals that then transition into symbols, is to look at something called Dean's blocks or base 10 blocks, after the math educator Zoltan Deans, who used these quite a bit. In this case, we're actually going to not use them in base 10. We're instead going to use them in base 3. So let's take our 23 objects. In this case, I've got 23 cubes being represented in base 10 as 2, 3. And if instead we wanted to bundle by threes, what would that look like? So what I'm going to do is I'm going to take my 23 cubes here, and I'm going to bundle them in threes. So there's 3, there's 3, there's 3, there's 3, there's 3, 3 more, 3 more, and now I've got 2 leftovers that aren't enough to put in a bundle of 3. Now the thing is, though, in base 3, what this would mean is I would replace each of these with what we often refer to as a long. It's basically 3's bonded together, so to speak. So I'm going to replace each of these with a long. Whoops. 1, 2, 3, replaced by that. 1, 2, 3, replaced by that. 1, 2, 3, replaced with that. And 1, 2, 3, replaced with that. But remember, we're in base 3, so every time we get 3 of something, we rebundle. So in this case, what I'm going to do is I'm going to take, every time we get 3 bundles of 3, I'm going to bundle those together. And that's going to form what we refer to as a flat. So replace it with that. Okay, I'm going to get 3 of these, replace them with a flat. And so now I can use these to write my numeral in base 3. So what this says is I have, each flat, remember, is 3 bundles of 3, so each contains 9. So if I were writing this in base 10 symbols, I would say I've got 2 bundles of 9, which is 3 squared, plus 1 bundle of 3, plus 2 left over. And if you check the arithmetic, this would be 18 in base 10, plus 3, plus 2, which indeed is 23. However, if I wanted to write this in base 3, I would pluck off the face values, 2 of that kind of bundle, 1 of that kind of bundle, and 2 leftovers. And so I would write this instead as the numeral 2, 1, 2 in base 3. Okay. You'll notice the parallel to this is similar to what we do in base 10, where we have so many 10 squareds, aka 100, that's hundreds place, plus so many tens, the base, tens place, plus the leftovers that don't have enough to bundle into a bundle of 10. So again, this parallels it. Now in base 3 numerals, if we wrote this all in base 3, this would be written as 2 times 1, 0 squared base 3 plus 1 times 1, 0 base 3 plus 2, because in base 3, 1, 0 represents 3, 1 bundle of 3 plus a 0 left over. So the parallels between base 10 and base 3 or base 5 or any base you want to pick mirror what we do in base 10. So it's not that we're going to teach children to write things in base 3 and expect them to write things in base 3, but rather it's the bundling process, the grouping process that carries over into what we do in base 10 that's exactly the same. So the process is important for being able to understand why we write the numerals the way we do.